Good day, this is Dr. Amudapriya, Associate Professor EEE, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will see about the necessity of frequency and voltage regulation. Regarding the power system control, we do have several different control actions which has to be performed in order to obtain a safe electricity generation, transmission and distribution. So what are all the different power system control actions which have been executed are speed control of the governor, speed regulation of the governor, control action on the boiler pressure, temperature and the flows. Then the speed regulation concerned with the steam input to turbine. The load is inversely proportional to the speed. So based upon this, the control action may take place. Governor senses the speed and gives a command signal. And finally, the steam input will be changed relative to the load requirement. This is how the power system control action is going to take place. We can detail it. The governor control. So what is a governor? It is a device which is being used to control the speed of a prime mover, that is a turbine. A governor protects the turbine from overspeed and it keeps the prime mover speed at or near the desired revolutions per minute. When a prime mover drives an alternator supplying the electrical power at a given frequency, a governor must be used to hold the prime mover at a definite speed so that a constant frequency can be achieved. And next, an unloaded diesel engine will fly to pieces unless it is under the governor control. So when considering the load frequency control, it will sense the busbar frequency and the power frequency. Difference is being fed to the integrator and then to the speed changer, and finally the tie line frequency is being maintained constant. Regarding the economic dispatch control, when the load distribution between a number of generator units is considered, then the optimum schedule will be affected when an increase at one replaces a decrease at the other. Optimum use of generators at each station at various loads is known as obviously the economic dispatch control. And next, regarding the automatic voltage regulator, it will regulate the generator voltage and the output power. Finally, the terminal voltage and the reactive power is also met. What is required is being met. Considering the system voltage control, it will control the voltage within the tolerable limits. I mean the devices like static VAR compensator, synchronous condenser, tap changing transformer, switches, capacitor, reactor, etc. And for security control, we do have a monitoring and decision control, namely SCADA can be used for that purpose. And next, if suppose the condition of the system is continuously being observed in the control centers by the relays, obviously any continuous severe problem under abnormal conditions may be quickly identified and it can be eradicated. Next, or control actions may be taken. Next, regarding the control, proper commands are being generated for correcting the abnormality in the protected system. If no abnormality is observed, then the normal operation will proceed to the next interval. Central controls are used to monitor the interconnected areas. Actually, the interconnected areas can tolerate a large load changes with the small frequency deviations. Central control center will monitor the information about the frequency, the generator unit inputs and the tie line power flows to which is flowing to the interconnected areas. This information is then used by the automated low frequency control in order to maintain the area frequency at the desired level. So this is how the control action or the operation action is being tied up with the transmission side as well as the transmission generation and the dispatch side.